Okay, now let's have a rundown on the derivatives of hyperbolic functions. So there are, uh, you don't really have to know this, but we have sine hx is equal to e raised to x minus e raised to negative x over 2. So if you want to find the derivative of sine hx, so it appears to be that we don't have to use quotient rule. You just have to find the derivatives of the terms in the numerator. So e raised to x and then plus e raised to, how do we apply power rule here? Okay. So this is equal to cosine hx also. So if you want to find the derivative of cosine hx, so let's give it a try. Sorry, wait. There's supposed to be a minus sign over there. That makes it a plus. So that's the main difference between this and this. It's the sign. So yeah, I'm just trying to show a point. What is the derivative of 1 for e raised to x? So apparently it's the same as sine hx. So clearly, we could conclude that d over dx sine hx is equal to cos hx. In the same way, cos hx, its derivative is equal to sine hx. Previously, we all knew that derivative of cosine x is negative sine x, but it's not the same case when it comes to the context of hyperbolic functions. We don't put a negative sign. It's just gonna be positive. So you have to know that particular detail. Now let's have a rundown on a few sample problems. Let's start from the beginning. So, okay, we have tangent. Actually, I think it's best if I list down first all of the formulas. So we already have for sine and cosine. How about d over dx tan hx? What is that equal to? I believe it's the same thing. Oh, wait, don't forget du over dx. Let me just confirm if that is correct. Yeah, it is. Okay, next. How about secant? Fortunately, I don't have the complete list. Let me just check if I have an extra copy. Okay. So, it's supposed to be like this. For derivative of secant hx, it's supposed to be negative tan hx secant hx times du over dx. And then d over dx cotangent hx is equal to negative CSE raised to 2 hx times d over dx. How about for cosecant? It's negative cotangent hx CSE hx times du over dx. Okay? You have to know all of those. It's your responsibility to find a way on how to get them to your mind. So once you see a problem, you know what formula to use. So here, it's going to be secant raised to 2 hx times du over dx. Our u is this, right? Or we could rewrite it as that. If you want to find the derivative, it's going to be 1 over 2 times square root of x. Further simplify. As tempting as it can be, that we might want to cancel, I don't think that's allowed. Yeah, it isn't allowed. Because this is the x coming from the trigonometric identity itself. At least that's the way I'd want to explain it. I am out of formality, I know. We could rewrite the final answer as this. Next. Okay. Sample problems. Let's try this. So, cosine h x and then derivative of what's inside this, so it's gonna be negative 2x. Don't forget the negative sign, that's part. Always. And this is the final answer, I believe. That's it. Next question. So, cosine h, right? Its derivative is sine h. And then just copy sine x. And then derivative of sine x is, don't be confused, it's positive cosine x. So, yeah, that's it. This is the answer already. Nothing else to simplify. Next. Y is equal to cos h cubed x raised to 5. So, cos h sine h. Oh, okay. I think we have to apply power rule here. So, bring down 3. Okay. So, if we encounter a problem like this, as tempting as we'd already find the derivative of cosine h, we can't because there's power rule. If we bring down 3, we copy cosine h and then place a raised to 2 and then just copy x raised to 5. Then we find the derivative of cosine h, which is sine h, and then just copy x raised to 5. And then you find the derivative of x raised to 5, which is 5x raised to 4. That's it. So, yeah. Three, 15 x raised to 4. You cannot multiply this with this. Again, this is one whole term. You cannot separate their x raised to 5, if you get what I mean. That's it. This is gonna be the last practice question. Then I'll end the video already. Product rule. Okay, we need to apply product rule here. Derivative of sine h x is going to be cosine h, and then just copy the x, which is 2x. And then derivative of 2x is 2. And then cosine h for x. Just copy, and then copy. And then derivative of g of x. So 2 cosine h 2x cosine h 4x plus sine h 2x sine 4 sine h 4x. I think that's it. This is it. Next video will be about ln method. So what, in extension to what has been taught earlier, I mean in the previous video, the video before this, I mentioned about what the derivative of a raised to x is. So you need to apply ln, right? So we'll be extending on that idea in ln method. So if you try to find the derivative of functions where a variable is in the exponential position, so you just don't solve it the usual way. You need to apply ln on both sides, and yeah, the rest I'll be explaining in the next video. That's it. Cheers.